Okay. So where we stop? Okay, note KVL, KCL, KVL. Okay. Now we go to series and parallel circuit. Okay. So okay, for parallel circuit, both ends are connected. Both ends of the resistor are connected, meaning that R1 and R2 is said to be parallel when both ends of the resistor are connected together. Okay. R1 and R2 connected here, and the other end is connected together. Okay. So find R equivalent for this circuit. Okay. So we start at the right side. Okay. And then we bring the equivalent circuit to R equivalent. Okay. So we start with this 5 plus 1 is equal to 6. Okay, and then we redraw. Okay, 4 here and then 2 here and then 6 is here. Okay, and then 6 and 3 is parallel. How to parallel 6 and 3? 6 and 3 is parallel. Okay, so this one is 6 parallel with 3. Okay, is equal to 2. You know how to parallel 6 and 3? Yes, right.
Yes, I know.
Okay, so no need to teach you, right?
Yes.
Okay. 1 over R A is equal to 1 over 6 plus 1 over 3. Okay. So RA is equal to
2.
1 over 6 plus 1 over 3 is equal to this. Okay. 2. Okay, so this one is considered as RA. Okay, so now 2 plus 2 is equal to 4 and then 4 parallel with 6. Okay, this one is 4 parallel with 6. Okay. Hamid. Hamid. Aiman Ahmad. Where is Hamid? Okay, Hamid. Did you get 4 parallel with 6 is equal to 2.4?
Sorry, doctor?
Echo. Did you get 4 parallel with 6 is equal to 2.4?
For it's for basta.
Get the answer or not?
Yeah, it's 2.4.
Okay. And then 2.4 plus 4 plus 8. Did you get 14.4? Yes. Okay.
14.
Did you get the R total of this circle? It is 14.4. Get the answer right. Okay, next. The next find R equivalent. R equivalent is here, meaning that you start with the right side and then bring it to the R equivalent. Okay, so 4 plus 5 plus 3 is 12. This is 12. Okay, and then please redraw. Okay, redraw. We have 2 here, 6, 1, and 3, and 4, and then 12. Now we know that 12 parallel with 4, we get 3, right? Betul tak? This 3 is equal to 4 parallel with 12. This is the sign of parallel. Asfar?
Yes, doctor.
Did you get 4 parallel with 12 is equal to 3?
4 parallel with 12 equals to 3. Yes.
Okay. Okay. And then please redraw. Okay, we have 2, 6 here and then 1 and then this 6 is equal to 3 plus 3. 3 series with 3. This is 3. Okay?
Yes.
Yes. This one is 3 plus 3. Okay, and then 6 parallel with 6 we get 3. The same number parallel we get half. 6 parallel with 6 we get 3. Okay, 2 parallel with 2 we get 1. Okay,
Okay.
Nabila Atika. Okay.
Okay, doctor.
10 parallel with 10 you get 10 parallel 10 get 10 get 5. Okay, okay, the same number parallel we will get the half of the number. Okay, so the R equivalent of the circuit is 3 plus 2 plus 1 equal to 6 ohm, equal to 6 ohm. Okay, okay, now the other example, calculate RAB. Okay, RAB is R equivalent of the circuit. It is R here. Okay, RAB is this one. This one is A. This one is B. So this is our AB. Okay. So we start with the right side. Okay, ni lain. Okay, how? 1 plus 5 we get 6, right? And then 6
yes.
parallel with 4, right?
Yes, 6 parallel with 4.
Okay, so 1 plus 5 is equal to 6, and then 6 parallel with, okay, it is better to write the name of the resistance. Okay, RB is equal to 6, this 6 parallel with 4.
With
Arash.
4. With 4.
Yes, Arash. Arash baru masuk Arash. Oh, Arash. Tak ada mic ke Arash? Arash? Tadi ada Arash. Mana Arash? Arash? Arash mana? Diana? Diana? 6 parallel with 4 you get?
2.4.
Again?
2.4.
Sini. 2.4. Betul tak?
Yes.
2.4 Okay. And then 2.4 is here. Okay, now you can redraw. Okay. 3. This one is 10. This one is 3. Okay. And then we have 6. Okay. We have 12 here. We have 1. Okay. Allah. Okay, so 2.4 is here. Okay, now we can we know that 3 is parallel with 6, right? This 3 is parallel with 6, right?
Yes.
Yes. Why? Because 3 and 6 share the same
No.
node. Okay. connected at both ends. One is here and one is here. This point is equal to this point. Okay? This point. So 3 is parallel with 6. 3 is parallel with 6. And then how about 2.4 and 12? 2.4 parallel with 12, right?
Yes.
Can? Because 2.4, okay, is here, same with the node of 12, and they share at this point, right? Okay. So 3 parallel with 6, Safiras, ada ke tak? Three parallel with 6.
2.
2 eh? Okay, 2.4 parallel 12.
2 juga.
Berapa? 2. Betul?
2.
So 3 here. 3 and 6 we get 2. Okay, and then we have 1 here. Okay, 6 and 2.4 we get bukan. 2.4 and 12 we get 2. Okay. Ada lagi? Okay, so now from here, 3 parallel with 2. We get 2 plus 1 is 3. 3 parallel with 2 we get Izzah Afiqah. Izzah Afiqah. Izzah Afiqah. Mana? 3 parallel with 2. Berapa? 3 parallel with 2.
1.2.
1.2 eh. Okay. And then kat sini 10 lah. Apa you all tak bagi tahu ni? 10 here. Kan? Okay. So now our R total is equal to, okay, 10 plus 1.2. It is equal to 11.2 ohm. Any question?
No, so far.
Okay, good. Not responding pula. Any question? No. Okay. The next. Any question? No. Okay, now calculate the R equivalent. R equivalent is here. So we have to solve. Okay. Okay, Izzah. Izzah, okay. Izzah, mute your mic. Okay. So now we start with here. 20 parallel with 5. Okay. So we have 8 here. We have 18. We have 9. Okay, we have 2. Okay. We have 2. We have 20. 20 is here. Okay, now we have 5. 5 is equal to 20 parallel with 5 and then plus 1. Try it. So RA is equal to 20 parallel with 5 and then plus with 1. Ha. Arash ada ke tak ni? Arash? If you cannot respond to me, so consider as absent. Arash? So Arash is absent Kishan. Betul ke ni? Pronounce your name, Kishan.
Yes, madam.
Kishan. Okay.
Kishon.
Kishwan.
Kishon.
Okay. Okay, now Kishan, please calculate 20 parallel with 5 plus 1.
20 parallel with 5.
Okay. Other student, please calculate 2.
5 resistance.
5 ohm, okay.
Yes.
Asfar, betul tak?
Betul.
Betul Okay, now yes, it is right because the answer is here. Okay, 5 and then 5 is here, okay, at this point and at this point, so we know that 5 is parallel with 20. Okay, and then we can add with 2, right? Okay.
Betul.
Yes. So
How to
RB
determine
apa?
How to determine the place for 20 ohm? Nak letak before 2 ohm ataupun after 2 ohm?
Oh, okay. Now if we redraw, this is A and then 18 and then we have 9 here and then we have 2 here and 20 is here. Okay. And then after we parallel this 20 and 5, it is here, right? Okay, it is here and this is 1. This is 20 parallel with 5. And then when we redraw again, okay, let's say we just put 5. Okay, 5 here. Or you may put 5 is here. So this is 20 and 2. Okay?
Oh, okay. Okay, nampak.
Dah. Settle.
Dah.
Okay, now.
Okay.
And now we know that 20 is parallel with 5. Okay? 20 is parallel with 5. And then we can add with 2, right? Okay. So let's say we name it as RB. So RB is equal to 20 parallel with 5. Betul tak? And then plus with 2 is equal to, siapa kan menjadi mangsa sekarang? Aiman Ahmad Hashim. Calculate it now. Aiman Ahmad. Are you with me? Okay, please.
Yeah.
Calculate.
20 it's
Oh,
6.
so many voices there. 20 parallel with 5 plus 2.
It's 6.
6.
Yeah, 6 ohm.
Right? It is right?
Yeah.
Betul 6 ohm Okay, so betul ke? 6 here, not 4.
It's 5 parallel 20, 4 plus 2, 6.
Okay, 6. And then 6 parallel with 9, we get 6 parallel with 9 and parallel with 18. No. 6 parallel with 9 first. Asfar?
Yes.
6 parallel with 9.
3.6.
3.6.
Yes.
And
3.6.
then 3.6 parallel 18.
3.6 parallel 3. Wait, 3.
3. Okay. So
Yeah.
meaning that here is 3.6 not
3.6.
3. So this one
No.
is 6. Okay. So any question? 3.6 parallel 18 you get 3. Any question up to here, class? Our class is till 12 or 1? 1.
Oh, 9 to 12 rasanya.
1 Okay. Okay. So I think we go to current and voltage divider. Or we can solve this question, number 14. Okay, using current divider. Okay. No, okay. So let's go to current and voltage divider. Okay. This is current divider. Okay. Okay, this is voltage divider. Sorry, this is voltage divider. Voltage divider deals with series circuit. Okay. Why? Because in a circuit or in a series circuit, the voltage drop across R1 plus R2 is equal to the voltage source. Okay. Why we call it as voltage divider? Because in a series circuit, the voltage source will divide its voltage to other series resistance. Okay. So this is the formula for voltage divider. Okay. Consider this circuit. Okay, so let's say we have a series resistor and then a voltage source. This is Vs, voltage source. This is R1. This is R2. So how to find VR1? R1 divided with the summation of all series resistance. Okay. Now we have 2 resistors only here. So R1 plus R2 multiply with the voltage source or the voltage supply to this series circuit. Okay. And then VR2. VR2 is R2 itself at the upper side divided with all the resistor connected in series for this path. Okay. So now we have only 2R, R1 and R2. Multiply by the voltage supply to this path. It is Vs. Okay. So now for this circuit, let's find V1. V1 is equal to, okay, 4 divided with all the R connected in series. We have 4 plus 2, okay, multiply with the voltage source supply to this series circuit. Okay, it is the summation of 10 and 8. Okay, so how to add 10 and 8? Okay, you have to look at the sign of the voltage source. Negative, positive, and then negative, positive, meaning that we can just add 10 and 8. Okay. So, Kishan. Okay. V1 is equal to, calculate it now. 18 multiplied with 4 divided with 6.
Okay, madam.
Ah,
18 divided by 6.
betul tak ni?
12 volt.
Okay. Kishan, is it right 12?
Yes, madam.
Okay, okay. Now we want to find V2. Okay, Kishan,
Okay.
proceed with V2 now. I want to write.
V2.
V2 is equal to V2 is equal to cepatlah Kishan. Kishan. Kishan,
Yeah, yes, madam.
give me the like this.
Oh,
Okay.
2
Yes. 2 divided with
divided with R.
and then 18,
Then-
right?
Yes.
Okay, then
Then
this.
yes, 6.
Okay, but why the answer is -6? Because okay, actually the current will flow from the source, will flow like this. Okay, when the current enter this resistor, the voltage drop is positive and then negative. Okay.
Negative.
Okay, this is the flow of current. Okay, and then it reach 2 ohm. The notation of voltage must be positive and negative. Okay,
Yes.
but the question put the other the other way. Okay, it is positive here and negative, so you just write V2 is equal to -6 volt
Volt.
because of this flow of current. So when we refer to this notation of V2, positive here and negative here, the current should flow like this. Okay, the current, if follow this notation of V2, the current should flow like this. Okay, that's why this flow of current is apa ni? Minus of this flow of current, right? So that's why we put minus. Okay, can understand or not?
Understand, madam.
Okay, good. Okay, now this is voltage divider. So please bear in your mind that voltage divider deals with series circuit. Okay. So the voltage drop across that resistor is equal to that resistance divided with all the resistors connected in series multiplied by the voltage source that supply to that series. Okay. How about this? Calculate V0. Okay. Abdullah Basam. V0 is equal to Abdullah Basam. Are you with me? Multiply with 16. Asfar, did you get 6.4 volts?
Yes.
Okay, good. Next, V of 6 ohm. Okay, here. V of 6 ohm is here. Okay, so now, who's next? Rosliana. Okay, cepat. Rosliana.
6
Divided with
6 tambah 2
2. Okay, multiply with
9 tambah 3.
9 tambah 3. Tak boleh. Okay, because this is the flow of current. Minus, plus. Okay, go there. And then plus and minus. So, okay, if we redraw, this is 9. Okay, and then we reach positive first, right? And then negative, right? Okay. So this sign is not as this sign. This is negative, positive, positive, negative. So the summation of voltage here must be, okay, let's say we want to find the voltage source. Okay. This is minus Vs. This is positive Vs. So now we apply KVL. Okay, to find the voltage source. So here Vs. Okay, let's start with negative Vs. Negative Vs. Okay, why? I start with the second sign. Negative Vs and then plus 9 minus 3 equal to 0. Vs is equal to 6 volts. So this is Vs. Vs is equal to 6 volts. Okay. Or you want to use the first sign. It is positive Vs, and then minus 9, and then plus 3 equal to 0. Vs is equal to 6 volt. The same answer, okay? Can you understand? This calculation, I use the second sign. This is the first sign. This is the second sign. Okay, and then current flows through here. This is the first. This is the second sign. Okay, up to you. Okay, now can you understand why we should 9 minus 3? Okay, understand or not?
Yes, yes.
Okay, so the answer is, this is the answer.
4.5.
Okay, get the answer?
Yes.
Not M, volts. Okay. Okay. Now. Malisa pula. Malisa, V of 5 volts. V of 5 ohm is equal to 5. Malisa, divided with
8.
5 plus 3.
Okay, and then multiply with the voltage source.
30 minus 10.
Minus ke?
Plus 10. Minus 8.
Good. Okay, now calculate. Did you get same as this? 20. Okay, Malisa.
Yes, 20.
Good. Okay, the next. Okay, that's for voltage divider, not current divider. Current divider deals with parallel circuit. Okay, why we call it as current divider? Because in a parallel circuit, the current source, mana current source? Okay, this is current source. This is voltage source, but the current that comes out from this voltage source is the current source. Okay, this is the current source. So for a parallel circuit, current source will divide. Okay, will divide its current to the parallel path. Okay, so I is equal to I1 plus I2. Okay, so I here is the current that supply to the parallel circuit. It might not be the voltage, the current source, but it is the current that supply to this parallel path. Okay, So now let's look at the formula of current divider. Mana? Current divider. Where's the formula of current divider? Okay. Yeah, it is here. Okay, this is the formula of current divider. Consider this circuit. We have R1, sorry. We have parallel circuit of R1 and R2. Okay, and then we have current source. This is current source or the current supply to this branch. Okay, we have R1, we have R2. So, I1, okay. So this is I1. I1, this is I2. Okay. This is I1. Okay, and then this is I2. So how to find I1? Okay, I1 is equal to R2. It is the resistor that connected in parallel with that R1. Okay, so R2 divided with the resistor that connected in parallel. Divided with the R1 plus R2. Okay, multiply with the current that supply to this path. It is I. Okay, let's say we have current source here. Okay, so I is equal to this current source. Okay, and then how to find I2? I2 is equal to R1. It is the resistor that connected in parallel with this R2 divided with summation of R1 and I2 multiply with the current that supply to this parallel circuit. Okay. Now, okay, let's say I add another example. Okay, add another example of this is an example. Current divider principle. Okay. Current divider. Current divider rules. Okay. So let's say we have this is 2 ohm. This is 3 ohm. And then we have current source 4 amps. Okay. So now find I1 and I2. This is, let's say, 1 ohm. Okay, how to find I1 and I2? I1 is equal to, this is I1. Okay. What is the R connected in parallel with it? 3, right? 3 divided with summation of parallel resistance. It is 3 and 2. 3 plus 2. Multiply with the current that supply to this parallel circuit. It is 4 amp. 4. How about this 1 ohm? Ignore. Just ignore. Okay, this 1 ohm is not related to current divider principle. Okay, so I1 is equal to this. How about I2? I2 is equal to 2. 2 is the resistor that connected in parallel with this path, divided with 2 plus 3, multiply with the current that supply to this parallel circuit. It is 4. Okay? And you get the answer. Any question?
No.
Okay. Are you okay? Or feel so tired? Or hungry?
Sleepy, madam, sleepy.
Sleepy? It is normal.
Kurang.
It is normal. Okay. Example. Okay, so now if we look at this figure, we know that this is parallel circuit where 6 is parallel with 3. Okay, so find I naught and V naught. I naught can be found by using current divider principle. Okay, because this is parallel circuit, but we have to find the current source here. How to find the current source? I is equal to V over R. Okay, but please make sure that this is the current source. Okay, current source is I total. Okay, so I total, I is equal to V total divided with R total. Okay, I total must be V total divided with R total. Okay, so now we have to find the R total. Okay, how about V naught? When we get the I naught, so we can find the V naught. Okay, so we should find R total first. R total is, okay, start from here. 6 parallel with 3 and then add with 4. Any question up to here? And we get 6. Rosliana boleh?
Doktor boleh.
Rosliana, okay?
Okay, doktor, okay.
Okay, good. Okay, now when we get R total, we can find the I total. Okay, I total is equal to V total divided with R total. V total is equal to 12 divided with 6, we get 2M. So this 2M flow here. Okay, 2M. Okay. Why we should find the I total? Rosiana?
Ya, doktor.
Why we find the I total?
Sebab nak guna tu, nak cari I.O.
Yeah, because we want to find I. Oh, because we want to use the current divider principle. Okay, in current divider principle, we must find the current that supply to the parallel path. Okay, so this 2M supply to this parallel path. Okay, so how to find I naught? 6. Okay, we take the resistance that connected in parallel with this path. It is 6 divided with 6 plus 3, 9, multiply with supply current. Okay, we get 1.333. So how to find V naught? V naught is equal to I naught multiply with 3. Okay, multiply with 3. I naught multiply with 3. So I naught is equal to 1.233. We get 4 volts. And then how about the power in 3 ohm resistor? How to find power? P is equal to I square R. Okay, P is equal to okay, how to find the power? P is equal to I square R, or P is equal to V square over R, or P equal to IV. Okay. But if you want to find the power of 3 ohm, this I is the current that supply to 3 ohm. R is 3 ohm. If you want to use the formula P power for 3 ohm, this V is the voltage drop on the 3 ohm. Okay, not the voltage source. If you want to use the P equal to IV, this I is the current that flows through 3 ohm. This V is the voltage drop on 3 ohm. Okay, not the voltage source. Okay, now we have I naught. It is the current flows to 3 ohm. So I naught is equal to 1.33 square multiply with R. Okay, any question? Yasin Albaya, are you with me? Because I will consider you Arash ada, okay? But maybe you do not have mic, so how about Arash ada? How about Yasin? If you still did not respond to me, so I will consider you as absent. Okay? Maybe you are online but you sleep beside your laptop. So how come I consider you as attend the class? Right? Betul tak Aspa?
Betul doktor, betul. Saya sokong.
Kan? Biasalah tu. Because this is at the morning, right? People tend to sleep until noon, right?
Hmm.
Macam biasa je.
Tak.
Tak kan? Okay. Okay, orang lain lah kan? I think we have covered current divider principle, voltage divider principle. I think you can self-study to, okay, for example, this exercise 2.13, how to find the voltage V0, okay? So, voltage V0, this is parallel circuit. And then we have current source here. So, it is easier to find the current that flows through 9K, right? And then
Yes.
after we get the current flows through 9K, we can find V0. How to find the current flows through 9K? By using current divider principle. Okay. And then the power supplied by the current source. So P is equal to I square R. Okay. We have I here. We just need to find the R. R is R total because this is the I source. Okay. How to find the power absorbed by each resistor? Okay, so let's use P is equal to I square R. So we can find power that absorbed by 9K by I square R. We have find the I not just now, so we can find the power. How about the power of 6K and 12K? The same principle, find the current flows through here first. Okay, by using current divider principle. And then you can find the power by I squared R. Any question on how to solve this question? The solution is provided, okay? Okay, and then how about this? The solution is provided. How about this? Find V1 and V2. Okay, so this is parallel circuit. And we have current source. So we can find V1 by finding the current flows through here first. Okay, by using current divider principle. Same goes for V2. Okay. The power dissipated in 3K and 20K. Okay. After we get the current, so we can find the power because power is equal to I square R. How about the power supplied by the current source? Also using P equal to I square R, but you have to find the R total of this circuit. Okay, this circuit you can rearrange. Okay, you can put the current source here. Okay, this is the original circuit. This is the original circuit. This is the original circuit. You can rearrange this circuit, okay, by placing the current source here, okay, and then 5K is here, 20K is here, and then 1K parallel with 3K here, okay, so that you can have better view, okay, on how to implement current divider principle. Okay, you can rearrange this circuit, but make sure that the connection, the node is remain the same. Okay. What else? After current divider principle, okay, why data transformation, maybe this will be covered next week. Okay, I think you should try it first. If you have question, cannot understand, you can ask me, you can WhatsApp me. Okay, any question? Okay, for example, this tutorial number 14, determine Vx. Okay, Vx. How to find Vx? Vx can be found by using current divider principle. Okay, because we have 6 ohm here, this 6 ohm supply to 2 ohm and this. Okay, but first you have to simplify this portion. Okay, you have to simplify this. Okay, make A parallel with 12 and then plus with 1.2, okay, and then 3 parallel with 6 and then combine with 4, it is series circuit. This part is parallel with previous calculation here, okay, and then lastly we get the parallel circuit. Okay, it is 2 parallel with 1 and the R equivalent here. It is the simplified R here. Okay, and then you can find the current flows through here. Okay, after that you can find the Vx of 1 and the power as well. Okay, power is here. Any question? Maybe we can discuss more next week. Okay, you just ask me whenever you want through WhatsApp. Yasin ada. Okay, any question? Class, before you leave this class, I want to take your attendance. Okay, before that, okay, please try this question. Make sure all of you get the answer. Make sure all of you get the answer. Try it now. Try it now. Before you leave this class, make sure you get the answer. Try it now. Do not leave the class. I want to check your attendance. Abdullah Basam. Asfa. Where's Hamid? Muhammad. Where's Hamid? Did you register with this class? Have you registered with this class?
Yes.
Have you registered with this class?
Yeah.
But your name is not listed here. Make sure that you have registered with this subject. Okay, class, please solve this question before you leave this class. Asfa dapat?
On the way, madam. Last
Okay,
question,
good.
C.
Good, okay. Zahirul Haq.
Yes, madam.
You masuk lambat ke?
Masuk lambat sikit tadi.
Afsal, masuk pukul apa?
Berapa 11 tadi?
Pukul 11?
Madam.
Afsal lambat?
Saya terlupa yang hari ni pagi.
Amboi. Sedapnya terlupa.
Tak ada sebab saya ingatkan petang. Saya tengok balik jadual pagi.
Ingatkan. You ada 7 minggu je tau. Jangan tertinggal-tinggal lagi.
Okey, doktor.
Okay. Zahirul Haq. Get all the answer.
Not yet. Tengah buat.
Kat mana sekarang? A, B, C?
B. Sekejap. Tengah buat lagi dulu.
Okay. Asfa? Got all the
Yes,
answer?
doktor. 6 kilo ohm tak dapat lah, doktor.
6 kilo? Okay.
Power.
Okay, find the
current.
Find the current flows through 6 kilo ohm first by using current divider principle. How?
I see. Padahal tak dapat. Okay.
Padahal tak dapat. Here. I2.
Nice.
Let's say this is I1. Okay. Actually, solution is provided.
Okay, dapat, madam.
Okay, good. I think we stop here, but please try other question, okay? If you cannot, if you are stuck, please ask me. Okay, actually we have covered for current divider, voltage divider, KVL, KCL, Ohm's law, okay? And then how about tutorial? You can solve number 14, 15, 16, 17 is okay. Yes, you can solve number 17 because this is principle of series and parallel R. Number 18, yes, you can determine I1. Because you can find by using current divider principle, KCL, okay? Then, okay, number 19, 20 also can, okay? Try it. R equivalent, okay, how to find R equivalent here? Okay, try. We have learned today. Find I naught, okay, I naught. Okay, so number 21 is principle of series parallel circuit and Ohm's law only, okay? I can be found by using I equal to V over R equivalent. 40 divided with R equivalent. So after you find R equivalent, you can find I naught. This is only the principle of Ohm's law and series parallel circuit. Number 22. Okay. Number 22. Okay, 22 is series and parallel circuit only. Number 4, 23. 23, okay. 23 is quite challenging, but you can try it. How about this? Okay. This is series and parallel circuit only. Number 24. Please try and
Right.
ask me which number that you cannot solve. Then we can discuss. Okay. 25. 25. You cannot find 25. For the following circuit will cause the current source to deliver. Because this is star delta transformation, we will learn it next week, inshallah. Okay. Number up until 24 you can solve. 25 you cannot solve because yes, you can solve because you have learned it last 2 years, right? Okay. But